Here is the problem, or the bullet rather, that stopped me in my tracks. An 8-gram bullet that is fired into an 11 kg wood block that is at rest on a wood table. The block with the bullet embedded slides 5 centimeters across the table. The coefficient of kinetic friction for wood sliding on wood is 0.2. What is the speed of the bullet? Let's draw what's happening here so we can understand visually first what's going on. So we'll just say this is the bullet, right, that is 8 grams that is being fired into a wood block of 11 kilograms that is at rest on a wood table. So this is our table. The block is wood, the table is wood, and the 11 kg wood block slides because of the momentum of the bullet 5 centimeters. That's the distance. We know the coefficient of kinetic friction given to us as 0.2. We are asked to find what the speed of the bullet is that caused the 11 kg block to move 5 centimeters. So let's understand what we know first. Let's try and write down what we know. So we know the 11 kg wood block. We know its weight because we know its mass. So its weight is a vector going downward, and it is balanced by the wood table, so it is balanced by the force normal. And as the block slides across the table, it will encounter a force of kinetic friction going in this direction, so we'll call that Fk. So first we can figure out what the Fk is. We know that we can figure out what the force of kinetic friction would be as the 11 kg wood block moves across the surface of the table. So let's find that out first. So force of kinetic friction by the formula is the coefficient of kinetic friction times the force normal. And the force normal is nothing but the weight in the opposite direction. So this is nothing but the weight, which is mass times acceleration due to gravity. So we know our coefficient of kinetic friction is 0.2 is given to us. The mass is 11 kg plus the mass of the bullet. Take into account that now the bullet is embedded in the mass block. So we'll write the mass as 11.008 kilograms. And our acceleration due to gravity is 9.8 meters per second square. When we calculate that value, I think we arrive at 0.2 times 11.008 times 9.8. This is 21.57 Newton. Sorry for the burp, I've been drinking. So now we know what our force is. So from Newton's second law, we know that force is equal to mass times acceleration. So we know what force is, and we know what our mass is. So we can find the acceleration as the block moves 5 centimeters. So let's find that out. Therefore, acceleration equals force over mass, which is equal to 21.57 newtons over the mass, which is 11.008 kilograms. So that will give us a value of 1.97 meters per second square. So that's our acceleration. So now what we can do now is, using this value of acceleration from our position formula, we can find out time. So we know our position formula as final position equals initial position plus initial velocity times change in time plus half the acceleration times the square, the change in time, the whole square. So our final position is 0.05 or 5 centimeters, our 0.05 meters. Our initial position is 0, initial velocity, the block was at rest. So initial velocity is 0. And our half acceleration is 1.97 as calculated. And our change in time, the whole square, is what we're trying to find out. So algebraically, this works out to 0.05 equals 0.985. That's 1.97 divided by 2, change in time, the whole square. And now, so we can calculate our change in time just by algebra, and that value of change in time works out to 0.2253 seconds. So now we know our change in time. Now we can find out our velocity, because acceleration, A, equals velocity over time. Therefore, velocity equals acceleration into time, which gives us 1.97 meters per second squared times 0.2253. So our velocity, what we end up with is a value of 0.44384 meters per second. So we found out our velocity of the block as it moved 5 centimeters. We are asked to find what is the velocity of the bullet. Now we can assume that the momentum is conserved, because that's the law of conservation of momentum. So we can say that the I'll just get another piece of paper here. We can say that the momentum of the bullet, denoted by this Greek letter, looks like a P, I don't know what it is, I forgot, equals the P of the momentum of the bullet fired equals the momentum of the bullet embedded in the block. So we'll just call that momentum of block. So we know momentum, the formula for momentum is mass times velocity. So mass of bullet times velocity of bullet equals mass of block times velocity of block. So we know these three bullet, block. We already know these three values. We're trying to find out the velocity of the bullet. So velocity of the bullet equals the mass of the block times the velocity of the block over the mass of the bullet. So the mass of the block with the bullet embedded in it is 11.008. 11 kilograms plus the bullet's mass times the velocity of the block. We found that out as 0.44384. 0.44384. Excuse me. 0.43. And we'll divide it by the mass of the bullet as 0.008. So when we do that, we find the velocity of the bullet as, wait for it, we find the velocity of the bullet as 610 meters per second. Oh, that's fast. That's gonna kill you, maybe. If it hits the right organ, like maybe if it's the brain or the heart or sternum, it may kill you. But not if it hits bone. Just kidding.